Before stars, galaxies, or even atoms, the universe existed in a radically different state. The very first thing was not matter as we know it, but an unimaginably hot and dense condition where energy dominated everything. There were no structures, no light traveling freely, only an expanding fabric of space filled with extreme temperature and pressure. This primordial state marks the earliest moment physics can meaningfully describe. At the very beginning, time and space were fused into a single entity, space-time. According to modern cosmology, they emerged together during the Big Bang. Asking what came before may not make sense, because time itself began in that event. The first existence was not an object, but a state, a quantum fluctuation of immense energy density. During the Planck epoch, less than a trillionth of a second after the beginning, the universe was smaller than an atom. Gravity, electromagnetism, and nuclear forces may have been unified. The laws of physics as we know them did not yet operate independently. This was the earliest definable phase of existence. Inflation followed almost instantly. Space expanded faster than light, stretching microscopic quantum fluctuations across cosmic scales. These tiny irregularities became the seeds of all future galaxies. The first structure in the universe may have been these subtle variations in energy density. As expansion continued, energy cooled enough to form fundamental particles. Quarks, electrons, and neutrinos appeared from pure energy through processes described by quantum field theory. Matter itself emerged from fluctuations in underlying fields. These particles represent some of the earliest tangible components of existence. Quarks combined to form protons and neutrons. Within minutes, nuclear fusion created the first atomic nuclei, primarily hydrogen and helium. However, no stable atoms existed yet. The universe remained a hot plasma, where light could not travel freely. After about 380,000 years, temperatures dropped enough for electrons to bind with nuclei. Neutral atoms formed, allowing photons to travel without constant scattering. This event released the cosmic microwave background, the oldest observable light in the universe. Dark matter, invisible but influential, played a crucial role from the beginning. Though it does not emit light, its gravitational presence shaped the formation of early structures. It may have been among the first stable forms of matter to influence cosmic evolution. The first stars ignited hundreds of millions of years later. These massive, short-lived stars produced heavier elements in their cores. Before them, the universe contained only the simplest atoms. Starlight marked the beginning of visible cosmic structure. Some theories suggest that quantum fields themselves are the true first entities. Even in a vacuum, fields exist everywhere. Particles arise as excitations of these fields. In this sense, the first thing was not matter or energy alone, but the quantum field's underlying reality. Other models propose that a singularity marked the universe's origin, a point of infinite density. However, singularities indicate breakdowns in our equations. They may signal that our understanding is incomplete rather than describe a literal object. In certain quantum gravity theories, space and time are discrete rather than continuous. The first existence could have been a network of tiny spacetime units, fluctuating and interacting at the smallest possible scale. Some cosmologists suggest that the universe emerged from a quantum vacuum fluctuation. In this scenario, nothing was unstable and spontaneously produced space, time, and energy. The first existence was a fluctuation that expanded beyond containment. Regardless of the model, the earliest phase was governed by extreme energy and symmetry. As the universe cooled, symmetry broke, separating forces and enabling complexity. The first thing may have been symmetry itself. What we call the beginning may simply mark the earliest boundary of observable physics. Beyond it, our equations fail. The first existence might be something entirely different from matter, energy, or space as we understand them. Ultimately, the first thing that ever existed in the universe was likely not an object, but a state, a condition of unified forces, extreme energy, and nascent spacetime. From that primordial moment, complexity unfolded. Everything we observe today traces back to that original state, where existence itself began.